Okay, real quick, since we only have a couple days left together, remember we're Friday, June 21st. It's on the review. Everything you need is on the review packet inside cover. We're going to be in Gym B. I had you guys write that down. So if you weren't here that day, we're in Gym B. Seat numbers are already posted on Classroom. So between now and next Friday, take a peek. Not right now, just take a peek between now and next Friday, because please don't ask me when you enter Gym B what my seat number is. All right, that's something you guys should know walking into it already. The supplies are listed on there. Now, I saw a lot of people grab some compasses and straight edges as you walked in. I'm not bringing those to the exam. You need one for me. You need to borrow one for me. You come to a review session. Okay, that's payment for borrowing one. Remember that. All right, I am not bringing any extra supplies with me. All right, so if you need a compass, a straight edge, I got no problem giving it to you, but it's going to, a review session will be payment. Tomorrow I'll post my review sessions. Okay, I'm here all week, by the way, Monday through Thursday. I'm here after school all week, and then I'll show you, I'll post on Classroom when my review sessions will be during exam week. All right, but remember, we're Friday in the morning. Okay, and we already talked, yep, it's a long day for you because some of you will have English in the afternoon right after, but all right, let's get to it. First question, I'm going to do 26. Let's go to 26. It's a part 2 question. Okay, 26 is a part 2 question. It is only worth 2 points. All the part 2s are worth 2 points. It should go quick. I say should because you got to know your facts. All right, this should not. Usually the part 2 questions require minimal work. You see it, you read it, you know what to do. Hopefully, cross your fingers, right? If you put in enough work. This one right here involves a circle fact that we'll need. You'll see 4 arcs are in a ratio. At this point in the year, I'm hoping we know what to do with numbers in a ratio, unless it's a partition question. All right, this is the only, unless it's a partition, we put X's with them. So go ahead to CD, DA, arc AB, and arc BC and throw 2X, 3X, and 5X's on them for me. Anytime I see numbers in a ratio, unless it's a partition question, I'm throwing X's with them. So 2X, 3X, 5X, 5X. All right, now we got to know what to do with them. The reason you put X's with them is so you can build an equation to solve for X. All right, so I have 4 arcs, all arcs of a circle up here. What can I do with those 4 arcs? It's not like tricky, or I don't think it is. You have all the arcs in a circle, and the circle adds up to 360 degrees. That's why you put X's with them, so you can say 3X, 5X, 5X, and 2X equal to 360. Solve for X, substitute them back in before I get to the next step. X equals 24, great, but we got to plug it back in to find all the arc measures now. So substitute it back in. And since we're doing a part 2 question, it's a good chance to remind you guys this all has to be done in pen, remember. Okay, everything done in pen. If you want to do it in pencil and go over to a pen before you hand it in to me, great idea. If you want to bring a erasable pen instead, another great idea. But remember, I cannot give you a new exam. So you just make a hot mess of everything. There's crossouts that I can't give you a new exam. All right, so keep that in mind. But this part would be done in pen. All right, everyone's got all 4 arcs now substituted in. Now we're going to find angle B. All right, now we need to find what angle B is. So circle fact right here. Anybody know that type of angle? Angle B. We call that an inscribed angle. Yes, inscribed angle. Perfect. Now we know the name. Now the next question is, what's the rule to find an inscribed angle in a circle? Dylan, half the arc it's drawn to. You are allowed to bring colored pencils and highlighters to use them on diagrams. That's fine. So if I highlight angle B, everyone see the arc that it's drawn to. It's going to be half, because you guys told me to say take half of, not just one arc, but a couple, ADC together. So that's what angle B is going to be. I have to take half of arc ADC. Half of the arc it's drawn to. If you weren't here on Friday, we talked about how to find an angle outside the circle. That was Friday's discussion. So we're going to take half of $120 when I add 72 and 48 together. Angle B, 60 degrees. Pretty quick, right? Pretty quick. All right, these part two should go pretty quick again, but there's a big if there, if we know our rules. All right, everyone all right with that one? All right, there's a part two. Let's go to a part three question, 33. It's going to show up. I just don't know where. Could be in part four, the proof. All right, and I don't know what type of proof it's going to be. Congruent triangles, quadrilaterals, similar triangles. I don't know. This one right here, I won't give it away though. Here we go. Statements, reasons. Whatever teacher is grading your regions, they are told to take a point off if you don't write in your givens, or if you draw an arrow from your givens to the statements column. All right, they are told to take a point off for that. So please write them all in. I don't care what you do now. That's your call. But day of the exam, make sure you write in all your statements because we are told to take a point off if you don't write them in or draw an arrow to them. And remember, the givens are provided for a reason. Use them all. Use them all. So we got some perpendicular lines. We know what they do. And we have a parallelogram up here, PQRS. So make sure you know which, because there's a couple quadrilaterals in that diagram. Make sure you know which one's the parallelogram. Not the middle one, the whole diagram is. Let's roll. Proving PT and RU congruent. All right, well, guess what? That's not going to happen until you do what? Prove the darn triangles. It's like a broken record, right? You can't prove those sides until the triangles are congruent. So let's do that. If you weren't here on Friday, I went over the 5 ways to prove triangles congruent, so no need to review. Let's start with the right angles so we don't forget them, because I know a lot of students always mark it in the diagram, but somehow it never gets into their proof. So let's make sure we get the right angles. So angle RUS and angle QTP are right angles. Some people use definition of perpendicular, and you guys know that's correct. I use perpendicular lines to form right angles. And next step, let's say they're congruent. Tell me they're right angles, now tell me they're congruent. All right angles congruent. I'll stick an A next to that. That reminds me I have an angle. You don't need to, that's not required, but I like to keep track. All right, 1 pair down, 2 more pair to go to get them congruent. I used the perpendicular lines already. Anybody see anything I could use because PQRS is a parallelogram? Make sure you know, and you can highlight it if you need to. Day of, we're talking about this whole thing right here, not the inside quad. That whole thing is a parallelogram. Stellan, what can I use?
QP and RS are congruent.
Okay, we can use the property opposite sides congruent. QP congruent to RS. In a parallelogram, opposite sides are congruent. And also notice there's sides in the triangles we want congruent. So that's going to help us out. So what were those sides again? QP congruent to RS. Okay, let's go over to our reason now. It's been a bunch of units. Parallelogram, because that's what I'm given, implies, and then use the property. Tell me the property that's being used in the statement, which is opposite sides congruent. There's a side down. One more pair to go, huh? I got a pair of angles and a pair of sides. Anything else in those two triangles that would be congruent here? What's good there, Cormac?
Angle R equals angle P.
Yeah, guys, it's just knowing your properties. This is a pretty darn easy proof. In a parallelogram, opposite angles are congruent. And that gets me a pair of angles in the triangles R and P. Parallelogram now. But instead now it's going to imply opposite angles congruent. And that gives me a pair of angles. We talked on Friday when I was writing down the 5 reasons. If you have 2 angles and a side, you're golden. It's just a matter of what method it's going to be. All right, because it's either going to be angle side angle or angle angle side. You got to determine what the deal is about that side. Finally, not finally yet, but almost there. Triangle QTP. A reminder, because teachers will take off here if they're correcting it. Make sure your angles and sides match up when you write this statement. Okay, just don't write it. The first triangle can be written anyway, but the second triangle's got to match up the sides and angles with Q, T, and P. And that would be S, U, and R. All right, what do you got there? What's the method out of the 2? Side is not in between, so it's going to be angle, angle, side. And there's a reason why we prove the triangle's congruent, so we could get PT and RU equal. And we all remember that one, huh? C, P, C, T, C. Not a bad, think you're lucky. If this comes up, this type of proof, a week from Friday, thank our lucky stars here, because it could be a lot worse. As long as we know our parallelogram properties. All right, anything else there? You know what's going to come up? Again, I don't know where, part 3 or 4, because you also know what's going to come up is this one. Go to 35, the coordinate. I just don't know where. Both of them are going to show up. One's going to probably be in part 3. One's going to be in part 4. I don't know which one's going to be where, though, because I don't have any advanced knowledge. So let's go over this big dog. 6 points. 6 points. Last question. If you want to go ahead and graph, I think the graph's on the next page or something, I think. As you're doing this, a reminder. This, right now, what you're doing, the graphing, can be done in pencil. The work we're about to do on the paper, though, has to be done in pen. A reminder of that, please. What you're graphing right now has to be done. It can be done in pencil, can be done in pen too. But the work around we're about to show has to be done in pen. All right, prove it's isosceles. What formula am I going to need that's not on the formula sheet? Distance formula, and this is why it's probably a good idea to graph. You can probably see what 2 sides are going to be equal here, so you don't have to waste your time doing the distance of BC. All right, so step 1, make sure it's organized. Like every coordinate proof, step 1, show me what you're going to take the distance of. We're going to do distance formula on side AB, and then right underneath it, we can do the distance of side AC. And they should come out to be the same. So I'll give you guys a minute or 2 to go ahead and find those distances using the distance formula, which I am not going to give it to you. It's on your formulas to know sheet. And hopefully they come out to be the same. And your calculator for both distances should be 5 radical 2. Make sure it is. All right, once we get it 5 radical 2, the next step, what did you just learn? We didn't learn it was isosceles. Okay, what did you learn about AB and AC by doing those distances? Are they parallel, perpendicular, congruent? And why? So AB congruent to AC because distances are equal. Step 2 is always what you just learn about those sides above. Parallel, perpendicular, congruent. And then step 3, now you can say, hey, this thing's isosceles and why. So triangle ABC is isosceles because two sides congruent. No problems with that little proof there. All right, next up, since this is a 6-pointer, it's going to require a lot of work. Well, let's move it. Move this triangle now. Translate it. Write 5 down 5 and tell me the new coordinates. State the coordinates. Write 5 down 5 and state the new coordinates when you go write 5 down 5. Let's make sure all our new coordinates match because we're going to need a few of those new coordinates next. Any issues moving them? Write 5 down 5. 3 negative 1, negative 2, negative 6, and 2 negative 8. Those look all right? All right, last part. Now we have to connect a couple vertices from our original triangle and our image to make our possibly a rhombus. So make sure we know which ones we're connecting here. Ready? A to A prime. A prime, C prime. It's not letting me. No. C, C prime. And then finally A to C or C to A. Prove that is a rhombus. Easiest way to do it? Rhombus. Hopefully, cross your fingers, that comes up next Friday. All 4 sides congruent. So I need distance again. But save yourself time. We've already found the distance of one of the sides, haven't we? So you can just recopy that now. You can call this step 4 and continue it on, or you can call it a new step 1. We don't need to show the distance of AC because we've done it in step 1 up top. So we can just say, hey, that's 5 radical 2. We don't need to do it over again. It's already shown. But you do need to show the distances now of the other 3 sides. So AC is taken care of. Now we got to do A prime, C prime, and C prime. And hopefully those also come out to be 5 radical 2. Take your time now. This one's not bad at all. It's just tricky to work with the prime and the regular coordinates at the same time. I remember that's what some of my students had issues with when they did this. They knew what to do, but had a difficult time dealing with those coordinates. And I think you guys could finish this up, right? Step 2, tell me what you learned about the sides. You tell me all 4 sides are congruent because the distances are equal. And then step 3, finally, why is it a rhombus? All right, so I'm going to let you guys work at your own pace right now to finish this up.